Hello everyone, very good evening. I welcome you all at India's most comprehensive preparation platform for all competitive exams, that is BYJU'S exam prep. So first of all, extremely sorry, this series for machine learning was supposed to start from 2 days before, but for some unavoidable reasons I could not start it. So we are starting from today itself. So the very first topic that we will discuss is the simple linear regression. So please try to understand that machine learning is actually a mathematical concept. So you may feel that it is more inclined toward computer science branch, but it will be more on the mathematical side. Okay. Good evening, Sandeep, Sudeep. Good evening, Fantu. So let's start this brief introduction of myself. My name is Vishal Rabatia. I have 10 plus years of teaching experience. Following are the achievements and areas of expertise. This is my Telegram group. If you guys have any doubt related to GATE exam for the computer science paper or DA paper, then not all the subjects of DA paper, either mathematics or machine learning. So if you have any doubt, you can ask me at this particular group and I'll be happy to answer. So please guys, the exam is closed, so I would suggest you all to participate in the test series so that you will be analyze yourself in a better way. And analysis is most important because, I mean, see, before you commit any mistake in the examination hall, if you have analyzed all those mistakes, then you can avoid most of them while sitting in the examination hall. So this is the leaderboard for the BYJU'S exam prep test series. You can participate in this as well. You can find the link for the BYJU'S exam prep application in the description. Okay, so let's start with the simple linear regression concept. So first of all, what do I mean by regression? What do I mean by regression? So I told you that regression is basically analyzing the number of independent variables with respect to a dependent variable. So there may be number of variables x, y, z, and based on this particular x, y, z, there can be an output variable. There can be an output variable. So that's the concept. Now the idea is in the linear regression. So today's topic will be linear regression, but the relationship between this independent variables and this dependent variable need not be linear. But if the relationship is linear, then we can use the concept of linear regression. So I'll detail this. So regression is a tool that allows you to estimate how a dependent variable, or basically the output variable, will change as you change the independent variables. That is, as you change the input, how your output is going to change. Okay. Regression models describe the relationship between the variables by fitting them over a curve, not basically precisely a line, but over a curve to observe the data, on the observed data. So please try to understand that you are actually trying to define an algorithm which will learn from the input that what type of output can be produced given a new input, right? So that's the analysis that it will describe that how your output will vary based on the input, and initially it will try to learn based on the observed data. Okay, so that will be some training data and there will be some test data. So if you have, let's assume that if you have a record of 1 lakh data points, then you will eventually you may use 65,000 for training the model, and then you can test over the remaining records so that you can analyze that how good is your model working, right? So this is the idea. Now it is in general it can be for any model, any regression model, but when we talk about linear regression model, then we will use the concept of a straight line. If we are using the concept of linear regression model, then we'll use the concept of a straight line. And the simple concept is, I hope that you all know the equation of a linear line. You all know y equals to mx plus c. So if I define the line as y equals to mx plus c, then this is your y coordinate, this is your x coordinate. This m gives you the slope of the line. Yes, this gives you the slope of the line, and this is the intercept, right? So we'll learn more. So basically the linear regression, simple linear regression model is related to the concept of this straight line fitting for the observed data. So it's normal regression, but when we say simple linear regression, why do we call it simple? Linear regression is okay, but why do we call it simple linear regression? Simple when there will be only one independent variable and one dependent variable. That is, when you are trying to find the relationship between exactly two variables, one of them will be independent, one of them will be dependent. As your independent variable will change, the value of your dependent variable will also change. So simple linear regression is a statistical model for establishing the relationship between two variables. So simple because it is trying to establish the relationship between only two variables, it will be simple. Tomorrow we'll see the multiple linear regression, right? So one will be independent and another will be dependent variable, and this will try to fit it over a straight line, right? So in the line, what all will be present? Slope will be there, intercept will be there, but we are not trying to learn a simple straight line equation. We are trying to learn something. So for that purpose, we will also try to minimize the regression error. We will try to minimize the regression error. So let us understand that what all these terminologies are. Okay. So what equation do we use? What equation do we use for linear regression? So this is the equation for linear regression. So please try to understand, there is nothing new. This beta 0 is actually, you can write it as y equals to c plus m into x plus some this epsilon, So y is basically the y coordinate, x is your x coordinate. This beta 0 is actually your intercept. This time what I'll use is beta 0 will work as intercept, and this beta 1 will be a slope. Okay. So guys, now the session actually starts. I will not use any handwritten slide because you all understand that it's actually a mathematical concept. So I'll have to explain so many things. So first of all, what do I mean by linear regression? Let's try to understand that this is your y-axis. This is your x-axis. And you have some observed data. So this is the observed data, right? Now, with respect to this observed data, you will try to fit this observed data with respect to a line. So let's see that if you use this particular line, it can be any line. Please try to understand. Sir, is simple linear is equals to linear regression? Simple linear regression is actually same as linear regression. The only difference is that in simple linear regression, there will be only two variables. One is independent, another is dependent. So x is your independent variable, y is your dependent variable. X is your independent variable, y is your dependent variable. Clear, Fanto? Okay. So you can choose any line, this line, or you can have some other line. You can have this line, intercept. So please try to understand. If you only change the intercept, what will happen? This line, if you do not change the slope, but you only change the intercept, then these are the two lines which are parallel to each other as the slope is same, right? Now, the another line can be, I may be short of colors, but that's fine, right? So the another line may be this. Please try to understand, right? Another line may be this. So the observation here is that these are the actual observed data points. When we talk about this, then what are they? So these are the observations. Basically, this is nothing but your training data. What type of data? This is your training data. So this is your variable x, this is your variable y, right? So please try to understand, you will have some data along with you, and then you will try to fit that data over a line. You will try to fit that data over the line such that this error is minimized, such that this error epsilon how did I define this? Is we eventually trying to minimize the regression error. So see, the concept is the line can be anything. As we change the value of beta 0 and beta 1, the line will change. Yes or no? As we change the value of beta 0 and beta 1, the line will change. Clear? Please guys, make the session interactive so that you will be able to understand maximum things. Right? So see, y equals to mx plus c. If you use the different values of m and c, the line will be different. That's the simple logic. If you keep the value of m same and if you keep changing the value of c, then the displacement only will be with respect to x-axis, that how far it is from x-axis. Clear? But otherwise, if you keep the value of c same and if you keep changing the value of m, then the slope will keep changing. That's the overall objective. So please try to understand that what will happen in the regression problem. That we will try to choose the values of beta 0 and beta 1. We will try to choose the values of beta 0 and beta 1 such that this error is minimized. Sir, what do you mean by error? So please try to understand. Get okay. This is the point x. Please try to understand that. Let's assume this is your x1 and this is your y1. This is the actual point. So x1, y1 is your original. X1, y1 is original, I would say, observation. This is the original observation. Now, when you put the value x1, in this equation y equals to mx plus c, then this will give you a new value. So, if you put the value of x, then this is the value of y. This is the value of y. Let me call it y1 dash, or let me call it y1 dash. So, y1 dash is what you are predicting. So x1 is your predictor and y1 dash is your predicted value. It is not the actual value, but your line is predicting that whenever the value of x is x1, the respective value will be y1 dash. But please try to understand. With respect to this white color line, I am calculating all the things. So what is the error? The actual value should have been y1. But it is actually coming out as y1 dash. So there is an error. What? So this, the difference between the actual value of y1 and the predicted value of y. The actual value of y and the predicted value of y is nothing but your error. Right? So what will happen? If you are trying to get the best fit line, what do I mean by the best fit line? The best fit line is a line with respect to which the summation of all the errors will be minimized. Clear? So let's try to understand here that, or let me go to a new slide so that things will be clear. So this is your y-axis, this is your x-axis, these are your data points, right? And let's assume that this is your line which you have calculated. So this, now let's try to understand the errors. So this is your error. Actually, this is the predicted value. So this is the predicted value. And this is your actual value, right? So predicted minus actual will give you the error. So here this is the error. In this case, 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 this is the error. Getting the idea? So I hope with respect to a line, if you are defining that, so please look at this line, that with respect to a particular beta 0 and beta 1, the line will be unique. With respect to a particular beta 0, sir, a function with some coordinate, how it can give error? Pantu, you are not trying to understand. The line is something else. The line is you are just trying to fit the given data. This yellow color or this yellow color cross are actually the actual data set. This is the actual data set and you are just trying to fit this data set with respect to a line. Please try to understand. Is it necessary that if there are 10 different points, then all those points will fit or will be collinear? Is it necessary that all those 10 points will be collinear? I hope you understand what I am saying. If there are 10 points, 2 points will always be collinear. 2 points will always be collinear. I understand that you can always draw a line such that the line crosses from those 2 points. But if there are 3 or more points, then it is not necessary that the line will cross through all those points. Yes or no? So let's assume that these are your 6 points. These are your 6 points and this is your equation y equals to mx plus c. Whatever. This is just an equation y equals to mx plus c. Now we are just trying to observe that if this value x1 is passed, then the actual output with respect to the known data set is y1, but you have predicted it as y1 dash. You have predicted it as y1 dash. With respect to x2, the value should have been y2, but you have predicted it as y2 dash. Clear? So if you are just trying to fit it on a line, then it is not necessary that the line which you are assuming will eventually go through all the actual points of the observation. Understood? 1, 2. Is it understood? That this is just an assumed line. Please try to understand. This may be a random line. This is just a random line, right? And then with respect to S3, this is the y3 and this is y3 dash. So you can call it y3. This is your y3 dash. This is your y4. This is your y4 dash. This is your y5. This is your y5 dash. This is your y6. This is your y6 dash. Please try to understand that we are eventually in the search of a best fit line. What is the concept of simple linear regression? So we are trying to obtain a best fit line. So when do we say that the line is best fit? When do we say that the line is best fit? A line is best fit line if the summation of error is minimum. Got the idea? So obviously we can understand that all the points cannot lie on a straight line. All the points cannot lie on the straight line which you are considering, but you need to choose a straight line such that the summation of the error is minimized. Yes or no? Got the idea that what am I trying to do here? Please tell me. Are you getting this? That what we are actually trying to do? So we have some data points or the observed data set along with us. So based on that observed data set, we are eventually trying to obtain a straight line such that the error is minimized. Clear? Okay. So please try to understand that we are eventually, what do I mean by error? So what is error here? What is error with respect to x1? The error with respect to x1 is this y1 which should have been the original value and the y1 dash which you eventually obtained. So you are eventually, this is the error with respect to x1. What is the error with respect to x2? Sir, error with respect to x2 will be that you are supposed to get a value y2, but you got it as y2 dash. So what is the difference? Clear? So please try to understand that if I say sum of the error, if I say sum of the error, then this will be y1 minus y1 dash plus y2 minus y2 dash plus y3 minus y3 dash. But please, one more thing which you need to understand here is, that some of them may be positive, some of them may be negative. Some of them may be positive, some of them may be negative. So if the value of y2 is more and y2 dash is less, then it will be positive. This difference will be positive. But there are some cases when y3 is less and y3 dash is smaller. So some of them will be negative. Right? So this function will not work properly. Sum of error. So if we just think of this, then may not work properly as some are positive and some are negative. Getting the idea? Some are positive and some are negative. So please try to understand that we will not use the direct error, but we will try to minimize the squared error, because if we are squaring something, then this value, whatever this error is, it will become positive. Whatever this value is, it will become positive. Whatever this value is, it will become positive. This value will become positive. This value will become positive. This value will become positive. So if we are trying to minimize this, then ultimately error will be minimized. Yes or no? Yes or no? So we will not use such type of error minimizing function, but we will use the squared. We will try to minimize the squared error. So please, let's look at this. How can we define the error? So let's assume, let we have observation with respect to n data points. That is xi comma yi, where I is 1 to n. So these are the n different data points. These are the n different data points. With respect to this, if I try to define a function which is error function, we can call it sum of squared error. Sum of squared error. So we can define it as, so please try to understand, sum of squared error. Let me write it as SAC. Sum of squared error. So this will be nothing but the summation of I over 1 to n. And please, this is the equation which we are considering. This is the equation which we are considering. So from here, tell me what will be the error. So the error will be nothing but y minus, please look at this, the error will be nothing but y minus beta 0 plus beta 1 x. Yes or no? Error will be nothing but y minus beta 0 plus beta 1 x. Yes or no? This is the error. So with respect to this x, if it was supposed to be y, then how much error is there? How much error is there? Yes or no? So we can eventually define the error function from here. That this is the value of error with respect to given values of x and y. Right? So if I try to fit it in here, then what will be the value? See, the actual value, so we are varying from I equals to 1 to n. So with respect to 1, this will be y I, and this yi is observed with respect to xi. So what value is actually observed with respect to xi? So this is the this is true output, and this is my predicted output. My line has predicted this particular value, and what will be this value with respect to xi? If I pass the value xi, then the value which I'll get in the output is beta 0 plus beta 1 xi. Yes or no? Then I'll get the value as beta 0 plus beta 1 xi, and I'm actually squaring this. Getting the idea? Because some of them may be positive, some of them may be negative. Clear? Sum of squared error. So these are all the errors. This is the whole thing. The true output minus predicted output will eventually define the error, and we have squared the error, and this is the summation of all these squared errors. Clear? Y divide by n? Y divide by n? We are adding all the errors. So please try to understand that y1 minus beta 0 plus beta 1 x1 is the error square, is the error with respect to x1 y1, plus we are saying y2 minus beta 0 plus beta 1 x2 square is the squared error with respect to x2 y2. So we are adding all the errors because the overall error has to be minimized. We are not trying to average it out. No. You don't need to average this. You don't need to average this. This is just the error function. That what is the actual, what is the overall error. We are not trying to average this out. This is the actual error. Got the idea? Clear? Akhil, you don't need to divide it. I did not say that we are trying to divide it. The objective, please, we are trying to obtain a best fit line. A line is best fit line if the summation of the error is minimized. Summation of the error is minimized. Clear, Akhil? So we are just simply trying to minimize, but simple summation will not work. Simple summation will not work. Some of them may be positive, some of them may be negative. So it may be possible that at one level the error is 100, at another level error is minus 100. So you will see the summation of the error as 0. You will see the summation of error as 0, but there is error. One is in the positive direction, another is in the negative direction. It does not mean that there is no error. But if you simply sum them up, it will come out as 0. If you simply sum them up, it will come out as 0, right? So that's okay. The concept is quite simple, that we are trying to obtain a line such that the summation of the squared error is minimized, because the simple summation of the error function will not work. Simple summation of the error will not work. Therefore, we are trying to minimize the summation of the squared error. That's okay. I mean, the error is, whether the error is in the positive direction or negative direction, the error is error, right? So here this error may be in the positive direction, but here is this much error. Here the error may be in the negative direction, but the error is this much. So eventually we are trying to observe a line. We are trying to observe a line such that all the data points are too close to this particular line, so that the error is minimum. Clear? So that's the observation. But okay, so this is the sum of squared error, that is my error function. Clear? This is okay. But now what is the objective? The objective is to minimize this. Yes or no? What is the objective? We are interested in minimizing this error. Come on. Now, my question is, I ask all of you that what should be changed if we are trying to minimize this particular error? What should be changed if we are trying to minimize this particular error? Look at this particular example. Look at this particular example. This white line may not be the best fit line. If I make some changes, let's use a new color. If I make some changes and if I use this blue color line, then perhaps the error will be somewhat reduced. If I use this line, then the error will be reduced further. Yes or no? Yes or no? With respect to this, error will be reducing with respect to respective points. Yes or no? So, what are we trying to do? We are trying to change the line. We are trying to change the line such that the error is minimized. So, in order to change the line, what values should be changed? In order to change the line, what values should be changed? Please tell me. In order to change the line, what values should be changed? Sir, in the equation y equals to mx plus c, if you are changing the values of m and c, the line will change. If we are changing the values of m and c, then the line will change. So in this particular case, when we say that we are trying to, our objective is to minimize this error, then ultimately our objective is to choose the beta 0 and beta 1 values such that this summation is minimized. Yes or no? Because we cannot change the value of xi, we cannot change the value of yi. The only thing we can change is that with respect to this xi, this difference is minimized. Yes or no? Please tell me that when we say that our objective is to minimize this error, then basically we need to choose the beta 0, we need to choose the values of beta 0 and beta 1 such that this error is minimized. Yes? In order to minimize the error, we have to choose beta 0 and beta 1 such that error is minimum. Now my question is, no, not the predictably values minimize. What are you trying to say? Predictably values minimize means? Sudeep, in order to minimize the error, we have to choose beta 0 and beta 1 such that the error is minimized. The objective is to choose such beta 0 and beta 1. Now, the next question is, will we try all possible values of beta 0 and beta 1? Yes, Sudeep. Will we try all possible values of beta 0 and beta 1? We are engineers. We know the concept of differentiability. We know the concept of maxima and minima. We know the concept of maxima and minima. But here there are two variables. One, the beta 0 value can vary, and another, the beta 1 value can vary. Yes or no? So in order to minimize this, you will use two different functions. What? That one, this sum of squared error function will be differentiate, not the differentiation, it will be the partial differentiation. Partial differentiation with respect to beta 0, and will partially differentiate the sum of squared error function with respect to beta 1. Clear? Now, please look at the equation that this is nothing but beta 0 summation of I 1 to n. So this equation is important. Yi minus beta 0 plus beta 1 xi square. So in order to solve this, we will have to expand this. So let's do that. This is delta beta 0 and this is nothing but yi square plus beta 0 plus beta 1 xi square minus 2 times of yi beta 0 plus beta 1 xi. Yes or no? If you open this square function, this will be the result. Right? Now, our objective is to differentiate it with respect to beta 0 only. So, it's a partial differentiation. When we differentiate yi square with respect to beta 0, what will be the result? So, it will be 0. It will be 0, yes or no? Please tell me. Bhai, if you are not understanding the mathematics, please let me know. Otherwise, it will become difficult. Hello? Clear? Okay. So that's the idea, because these are the things which are important. So when we differentiate yi with respect to beta 0, it is 0 because it's a constant. Now, when I differentiate the second term with respect to beta 0, tell me what will be the result. I want all of you, see please, a little bit of mathematics is required, but I want you to solve this. When we differentiate beta 0 plus beta 1 xi square with respect to beta 0, what will be the output? Or you guys can try the complete differentiation or complete partial differentiation of this particular thing with respect to beta 0, then in a while I'll write this. Try by yourself first. No, not 0. For this complete expression, it will not be 0 beta, because beta 0 is present there. See, with respect to this, you can actually expand this as beta 0 square plus beta 1 square xi square plus 2 times beta 0 beta 1 xi. So what will happen? This term will become 0. This term will become 0, but beta square will become 2 times beta 0. This will become 2 times beta 0. This term will become 0. Now with respect to this, it will become 2 times beta 1 xi. Sorry, plus 2 times beta 1 xi. So done with this particular term. Sir, with respect to this, there is only one term of beta 0, so it will be minus of 2yi. Yes or no? Yes or no? Please tell me whether this will be the solution or not. This will come out as 2 times beta 0 plus 2 times beta 1 xi minus 2 times yi. Yes? अरे बोल तो दिया करो कम से कम. Right? Now, in order to minimize, differentiation alone will not work. In order to minimize, what we need to do? Let me solve it at the later point of time. In order to minimize this, what we need to do? Sir, in order to minimize this, we need to equate it to the 0. We need to equate it 0. When we will equate it to 0, then we will get the value of beta 0 such that this function can be minimized. We will get the value of beta 0 such that this function can be minimized. So, we will do this. So, from here, what will be the value of beta 0? From here, what will be the value of beta 0? Tell me. Sir, this can be seen as beta 0 is here. So, this yi will go in the... So, 2 is common. So, you can actually say this 2 got divided. I mean, 2 is dividing 0. So, it's simple beta 0. It will come out as yi minus beta 1 xi. This is the value of beta 0. Is it okay for everybody? though it is dependent on beta 1, obviously it will depend on beta 1, but yes, when we differentiate the sum of squared error with respect to beta 0, then this is the output which we will get. Clear? Now let's try to differentiate the same thing with respect to beta 1. Let's try to differentiate the same thing with respect to beta 1. So we need to equate to 0 what? Partial differentiation with respect to beta 1 of sum of squared error. So we can simply write this function, whatever it is, yi square plus beta 0 square plus beta 1 square xi square plus 2 times beta 0 beta 1 xy. See, you don't need to remember everything. It's just the simple concept. You just need to understand that we need to minimize the sum of squared error, because we cannot simply minimize the sum of errors, otherwise it will become incorrect, because some of them are positive, some of them are negative. So 2 times beta 0 yi, 2 times beta 0 yi, and 2 times beta 1 yi xy. This is minus. Also minus 2 times beta 1 yi xi. Clear? Yi b1 xi. Yes, it is beta 1. So we will try to understand that if I try to differentiate with respect to beta 1, this will be 0. This will be 0. This will be 2 times beta 1 xi square. This will be 2 times beta 0 xi. This will be 0. This will be beta 1. Therefore, it will be minus 2 times yi xi. Yes or no? This is the value. Please check this. Yes or no? Right? So from here, this is actually nothing but 2 times, remove all these 2's. So it will become beta 1 xi square plus beta 0 xi minus 2 times, sorry, again 2. Minus yi xi, and this is needed to be equated to 0, right? So what will be the value of beta 1 from here? What will be value of beta 1 from here? Sir, beta 1, oh, summation. We have simply removed this summation. This will be there. Sorry. We only focused on one thing. But this is summation I varying from 1 to n. This is summation I varying from 1 to n. Yes or no? Just from the simple aspect that yes, it is with respect to ni. So we will eventually think of it at the later point of time, but yes, this should be considered. Beta 1 and beta 2 are dependent. Yes, they will always be dependent. They will always be dependent, because you cannot change one value without thinking of the other one. Right? So, so this is nothing but the summation of I varying from 1 to n yi xi. Let's do it minus outside plus summation I varying from 1 to n, and then I can say this beta 0 is outside, so this is xi, then this is beta 1 summation of I varying from 1 to n xi square. Clear? This is the value of I mean, this should be equals to 0, not value, right? This should be equals to 0. So please, when you will solve this, this value of beta 1 will be what? Sir, value of beta 1 will be, this is the first term. So, summation of I varying from 1 to n beta 0 xi minus summation of I varying from 1 to n yixi divide by this is summation I varying from 1 to n xi square. Yes or no? Can I write it in this particular format? Can I write it in this particular format? Please tell me. From here, we are just trying to define that, okay, if I just rewrite it in this particular format, then I can represent it like this. B0 before, yes sir, B0 before, what are you saying, B0 before? Akhil, B0 before, did I write something which is not correct? Clear. Okay. Please try to understand. If just a little more mathematics here, and you will eventually understand that if I take xi outside, then it will become xi minus yi. So please try to understand, y minus beta x will become what? Y minus beta x will become what? So this value is the yi value, that is the actual value. This xi is the original value, and this xi is the original value. With respect to this, you can define the function in this particular manner. So this is one function, right? This is another function. You will do some little more mathematics. See, I'm not going into that particular mathematics, but what two equations you need to remember is that beta 0 can be written as, what is this? Sir, this is the original value of y. This is the original value of y. Beta 0 is the original value of y, but please, there are too many values of n. So if we try to average it out, then we can eventually denote it by divided by n, right? So please, rather than thinking in terms of individual function, we'll simply write y bar. So it is nothing but mean of y. This is nothing but mean of y. This is the last thing. Can also write beta 1. See, what you are trying to write here is the written formulas or the mugged up formulas. So, but I am just trying to give you an intuition that how the values can be derived, so that somebody who is not comfortable in mugging up the formula will also be able to derive it and will also be able to correlate with the concept of machine learning, right? So this is y bar, and apart from that, this is nothing but your beta 1. This will be with respect to beta 1. So this is the observed beta 1 value, whatever beta 1 had, whatever you have observed with respect to xi bar. You can actually see both xi and yi are from the database. So yi values will be already known to you, xi values will also be known to you, but here we are just defining the mean of y and x, or you can say mean of y, mean of xi. Clear? Now, when we talk about beta 1, so this is the formula for beta 0. With respect to this, numerical problems can be asked. Another one will be beta 1. So how do we define beta 1? So beta 1 will be summation. I'm not going into the mathematics of this because the algebra will be too heavy on this particular aspect, but yeah, certain things has to be remembered. So you can actually see xi, this will be nothing but yi minus y bar. Please look at this. let's look at this particular formula. This yi is the original value. This yi is the original value, but when we say beta 0 xi minus xi, beta 0 xi minus xi, and this xi is square, right? So we can rewrite this. We can rewrite this from taking xi common from here. We can rewrite this from taking xi common from here. Therefore, I am not going into the algebra. Just let me write the equation. That this is one equation. Then the remaining, sir, is this notes will be gonna available? Yeah, I'll upload them. That's fine. I'll upload them. So it will be summation from I over 1 to n. This will be xi, and finally it will be xi minus x bar. So I hope you understand what are the values xi, what are these values xi, and what are x bar and y bar. X bar and y bar are basically the mean, and the xi and yi are the actual points. Xi and yi are the actual points. Clear? So how these two equations are derived? How these two equations are derived are basically nothing but you have the sum of squared error function. You have the sum of squared error function. You will differentiate that sum of squared error function with respect to partial differentiate with respect to beta 0, so that you can obtain the equation for beta 0. You will also differentiate it, partially differentiate it with respect to beta 1, so that you get an equation for beta 1. Now you can solve these two values of beta 0 and beta 1. You can use these two values for beta 0 and beta 1, and by applying some more algebraic concept, you will be able to achieve this equation, right? So these are for n points. I can simply say y is nothing but x y1 plus y2 plus y3 up to yn divided by n. Xi bar is nothing but x1 plus x2 plus x3 up to xn. Clear? So this is the idea. Done? See, some other mathematical concept can also be used. This is known as ordinary least square. Ordinary least square, because we are simply trying to use the simple mathematics for this particular purpose. So other regression problem may be more difficult, but in this particular concept I just wanted to explain one simple thing, that what will happen in the simple linear regression. You will have some data points. You will try to obtain, in the simple linear regression, you will try to obtain a line such that the data which are available to you are best fitted with respect to that particular line. How do we say that the data is best fitted with respect to that particular line? We will say that the data is best fitted with respect to that particular line if the error is minimized. In order to minimize the error, we can simply use the concept of summation of the error, but it cannot be used because some error will be positive, some error will be negative. Therefore, we will use the sum of squared error. So once we obtain the sum of squared error, in order to get the straight line, what you need? In order to get a straight line, you need one is the intercept, another is the slope. That is, you need the value of beta 0 and beta 1, so that this sum of squared error can be minimized. In order to minimize this, you will have to differentiate it with respect to, or partial differentiate it with respect to beta 0, with respect to beta 1. You will get some equation, and ultimately these two equations can be directly used. These two equations can be directly used. Clear? So these are the simple equation. Don't worry that this is the summation. So if I differentiate it, summation of yi from 1 to n, so it is nothing but average. It is average, yes or no? So this is also beta 1 is outside, summation of xi, so it's nothing but average. Clear? So that's what we are doing. So we can move this x summation inside with respect to these different values, and we will, so this is nothing but xi bar. Clear? So therefore this is beta 0 xi bar. Clear? So from here we are using the value of beta 0 actually. What is happening? Here we are using the value of beta 0 and then we are solving the equation. Clear? So I can also say that data points are linearly dependent, that points are some k multiple of each other in best case. See, please try to understand, we are not going in too much theoretical concept, but when we use the concept of simple linear regression, then the model will perform good only if some assumptions are met. What are those assumptions? So when you say that they must be linearly dependent, yes, if the data is not linearly dependent, then you will not be able to obtain a line which will be best suited for the data points which are available to you, because the data may vary something like this. So in this particular case, no matter how good the line is, there will be some error. There will be some error. Clear? Clear, Fanto? So what are the model question asked for regression? See, model questions can be like that they can give you some data points, that some values of xi and yi are given. Some values of xi and yi are given. So please try to understand, if some values of xi and yi are given, will you be able to calculate the value of beta 0 and beta 1? If the values of xi and yi are given, will you be able to calculate the value of beta 0 and beta 1? Akhil. So they can give you 10-15 values, that this is the observed data, that when x equals to 2, y value is 5, when x equals to 3, y value is something else, when x equals to 7, y value is something else. So based on that, you can perform, or you can use that particular data to calculate the value of beta 0 and beta 1. Right? So these are the numerical type of problem that can be asked. Clear? Will you give some practice questions or DPP? Rohit, we'll solve some practice questions, but when we are in that particular situation. That means, first of all, I'll try to discuss all the mathematical and theoretical concepts, and then we will try to solve some practice questions. Clear? Obviously, practice questions are required, otherwise there's no point of defining all this mathematical aspect. But I mean, the time is limited, so clear? So is there any doubt with the simple linear regression? The concept is very simple, that based on the values of x and y which are available in the training set, we'll try to obtain a line, such that the error is minimized. So the line with respect to which the error is minimum is known as best fitted line. Clear? So with respect to this, do you realize one thing? That this is an squared error function. So please tell me, this is an quadratic equation, therefore it will be like a parabola. So if you are trying to go into more intuition, then this is your sum of squared error, right? So we are eventually trying to differentiate it. This error function such that the error is minimum, that is when slope is equals to 0. I don't know how many of you have understood the calculus in detail, but the differentiation of a function will eventually provide you the slope. So when slope becomes 0, at that point of time, there will either be minima or maxima. But because it is a quadratic equation, and both the values of the coefficient of x square is actually positive, therefore it will be an upward slope. So wherever you get slope equals to 0, there will be a global minima. Therefore this equation is working, that when we are differentiating it with respect to beta 0, partially differentiating it with respect to beta 0 and beta 1, then the values which are obtained are guaranteed to be with respect to minima. Otherwise, when we differentiate something with respect to x and equate it to 0, then at that particular value of x, there may be minima, there may be maxima. Yes or no? So similar type of equation may also maximize the error, but in this particular case, error cannot be minimized, therefore because the coefficient of all your square terms are positive. Clear? Clear, Baba? So I guess this is it. This much is sufficient for the simple linear regression. You don't need to go in too much detail apart from that. See, for subject is not difficult, but it's just that whether you are getting it in the correct manner or not. So Obviously, there are many other regression techniques for the simple linear regression, but the most common and most famously used is this least square error, that we are eventually trying to minimize the square error. Okay. So this is it with respect to this particular session. Tomorrow we will also we'll revisit the concept of simple linear equation, and then we'll try to modify the concept of simple linear regression with respect to multiple linear regression. Multiple linear regression means what? In multiple linear regression, there will be multiple independent variable and a single dependent variable. Multiple independent variable and a single dependent variable. So tomorrow we'll try to learn the concept of multiple linear regression. That is all. So if you guys have any doubt related to GATE preparation, then you can join this Telegram group and ask me at this particular group. I'll share the PPT on this particular group. Okay. So today's class PPT will be shared in this particular Telegram. Clear? Thank you everyone for joining the session. If you like the video, then please hit the like button. If you are new to the channel, then subscribe for the channel and press the bell icon so that you will get the notification about all the videos of machine learning. That will be all. Thank you very much. Keep learning. Good night. Take care.